Read along with me.
What change?
It's about page 3, I don't think it's marked, but at the heading it says, road water harvesting defined. The proper techniques in designing and installing a road water harvesting system have as much or more to do with re-establishing and rebalancing surface water flow within the watershed as much as it has to do with reducing road maintenance. This is the big deal behind draining roads. Okay. All right. Calculation of surface water moved back onto the watershed by using proper road water harvesting techniques can be calculated in the tens and hundreds of acre feet. What's an acre foot of water worth if you go buy it in New Mexico? Buying water lately?
Your firstborn.
Huh?
Your firstborn.
Damn near. This amount of water is very significant to restoring proper functioning conditions in your watershed. Properly designed and executed, the system of harvesting rain, snow runoff, water runoff, roads, redistributes its surface flow back onto the downslope watershed. This redistributed surface flow promotes vigorous vegetation, creates small ephemeral water holes if you dig them out right, if you got clay, for wildlife and livestock, decreases erosion, sediment flow into the main stem waterways within the watershed. This rebalancing of local micro watershed rehydrates the downslope side of the road, which has been dewatered by the road's diversion of natural surface flow. This rebalancing of surface flow creates the proper functioning conditions within the micro watersheds, thus reducing erosion, gully formation, sediment load into the overall watershed system. This type of road water harvesting is especially useful where roads parallel or cross riparian areas or clear water stream systems and fisheries. Okay. We reintroduced the Rio Grande cutthroat trout into Comanche Creek to the Bahia Vidal by cleaning up the water in the creek. The problem with the creek was too much sediment, which gave us temperature problems and spawning problems because it covered the gravel riffles. Where was most of that sediment when we did the watershed assessment, Bill Zedek and I, where was most of the dirt coming from the roads? The roads. We drained those roads. We got on this Forest Service and we changed culverts around so we could dump them into areas where we could, diffuse that water and spread that sediment out. It was the number one thing, other than a big bank erosion where the stream had gone into this bank with a hillside cut that was dumping a couple 300 tons of dirt in the creek every year. That evulsion was caused by the creek getting plugged up and slamming into the side of the hill by too much sediment in the creek that it couldn't push downstream, so it backed up and went into the hillside. Where'd the sediment come from? Roads. We went in there and drained all those roads that were problematic and totally changed the dynamics of the water. We also did in-creek work where we stabilized creek bank erosion too. We did those two things, but the biggest dirt predator there was the roads. Okay. By diverting the road surface flow off the road before the flow reaches the stream system, the amount of sediment into the stream is greatly reduced. This reduction in sediment contributes to the stream's reduction in total maximum daily load. That's how they measure this. Okay, you can actually measure sediment overloading in the stream that can trigger undesirable geomorphic evolutions of the channel morphology such as bank erosion, mid-channel bars, as well as covering up the stream channel bottom gravel, which is necessary for fish spawning. Okay. Conclusion. It is a known fact that roads within our watersheds are the biggest impediment to proper water functioning conditions. Therefore, road water harvest is one of the best and most economical ways to restore proper functioning condition to your watersheds. If you don't believe my BS, read some of these right here. Okay. This top one is Watershed Analysis, whereas I should have written that out because I never can remember what it says. An assessment by Raj, how to chase sediment. Okay. Thank you. So, does that give you a big picture? I just asked a question, yes or no? I mean, is this thing, I mean, what are we dealing with here? We're dealing with a big problem. Okay. Okay. I noticed here buffers. The discipline of harvesting water roads includes these disciplines and some basic knowledge and understanding. Geology. That drives our soil type. Okay. Geomorphology. That's the effect of change on Earth. It could be fluvial geomorphology that affected water. Parentheses, soil type also. Hydrology, you kind of understand how water works. Ecology, that's vegetation. Okay. And the animals that use that territory. Okay, you've got to tune in to not only the road but the holistic view of things, because you're working with this. You're going to trigger things to work better, mostly on erosion and water harvesting for vegetation. The other thing that we discovered yesterday, taking who knows Kate Ziegler, the well lady. Everybody knows Kate. Talking to Kate yesterday, and we both did presentations, that we're having a problem with wells. Well, by golly, if we keep water on the land for it, we're going to help recharge some well systems. Might take some time. But here's what happens. Okay, to the road. I'll lay it in red. The road's bad. So here's your road. Down a hill. Sloping. Here's your hill sloping into the road. There's the water coming off the hill. There's the water coming down the road. Now, collectively, what happens? This is called collateral flow when it comes off the uphill outside of the road. This is called road surface collection. Okay. So now, where do we got? We got water going down the road. Listen very carefully. It's not getting off the road. Let's just say it comes all the way down the road. Hits a ditch or gully. Goes down here, goes into the creek, goes a little further, goes into another creek. It leaves the ranch. You poke a hole in the bottom of your gas tank on your pickup truck in the morning and then get in it and drive it. That's what you're doing there. It leaves the ranch, once it's in the ditch, and once it's in the gully, and once it's in the Canadian River, you've lost every opportunity to put that water to beneficial use because you're not willing to manage the water problem. The road washes away, you lose all the water, you beat up your equipment, et cetera, et cetera. You keep working on the road because it keeps washing out. You know, you do this right, you won't touch the road. You'll barely touch it. Take that road grader and sell it.
Get a dozer.
Huh?
And get a dozer.
Yeah, there you go. Probably be better off, actually. So, does that make a picture for you? Okay. Troy. I don't mean to put you on the spot. I've had the pleasure to work at Cowboy with Troy and Brian and these guys, and it's just great. You know, I got to know Troy and Lori, and we've had a lot of fun, and I've watched Troy a lot. He's taught me a lot, so Lori has too. Lori's one of the best cowhands you'll ever work with. So Troy, based on this concept, is it smart or stupid to let water go down and leave the ranch? That's the only thing I can think to say.
Obviously stupid.
Yeah, it's obviously stupid.
Yes.
Okay. I'm not trying to put people on the spot, I'm trying to make a point, you know. But I'm introducing some new ideas to a lot of you. And when we see a new idea, we go, oh, I don't know, you know, that's gonna take change, I don't know if I'm gonna change. But I wanna drive in some stuff because what's the two most important things in ranching to produce livestock? Two things. Grant, two things. The most important things to grow a cow.
Water and feed.
Exactly. Now let's feed the cows, Grant. Let's go down the road. We'll put some rolling dips in here. This is it, guys. This is really simple. We're going to study some other stuff. This is the foundation. Now where's the water going? Tell me, Grant, where's it going?
On the ranch.
On the ranch. Is it better to keep it on the ranch or send it down the gully?
On the ranch.
Yeah. The more goes to the Cimarron. The Cimarron goes to the Pecos. The Pecos goes to the Rio Grande. The Rio Grande runs into the ocean.
Third, not
Did I miss? Is there something?
water to the Canadian, to the red, to the Mississippi. We're
Oh,
in
it goes into the.
We're in the Mississippi River.
Okay, thank you. I didn't know if that was right or not. Thank you. But anyways, it goes into the ocean. Now, you want to go to Louisiana and collect back some of your ranch out of the Delta and haul it up there in the dump truck along with the water truck. You can suck out a big old lot of water and bring it back up here.
Yeah.
So it goes,
And the
okay,
lakes
wait a
are-
second. Mora, Cimarron,
Canadian, more Canadian.
oh, wait, Canadian, Red,
Red in Mississippi.
Mississippi. Okay. I
There's
should know
there's
that. I
actually-
should know that.
Probably doesn't make it past.
I made that mistake yesterday.
Yeah.
See, I made that mistake yesterday.
Yeah, There's
So
actually,
Grant,
there's actually a website you can, it says drop a raindrop, and you can pinpoint anywhere in the United States and it'll show you exactly the whole path that water drops.
well, now what do we got here, Grant? What do we produce?
Feed. Grass.
Some grass, right? We got this critter down here. I'm a really good artist.
I don't know what that is.
Let's see if I get it right. Oh, it's not right, that's not a backwards line.
No one draws an arrow like you do.
Oh, here. How about this? We'll do this.
An asterisk. Wow. Hey, I reckon I know that cap.
What's your brand, Troy? It's an R or something, right?
Backwards L with the bar underneath.
Okay. Well, we could brand him on there. What's your brand? You put your brand on there. Mike, what's your brand? You put your brand on there. Say.
I don't know if I want my
So this is a Mauritanian rock cruncher. He's special breed. He lives down there in the canyon. Okay, I think you get the point. All right. Any questions? This is a funny way I start this. This, as laminated, throw your pickup correct, go out, do that. I'll go over it. Okay. Here's where we screw up. Here's where Steve has screwed up. Here's where most of you will screw up if you don't pay attention. Okay. It's on your handout here. I just give you my notes so you can kind of follow along and then you can scribble on there. Oh, who brought a clinometer? Oh my goodness.
I was gonna say, I wanna see one of
Who's
those.
Is it on your phone or is it on your?
So I got both. One on my phone and one on my.
Your hand. See, she knows what the heck's going on. And you use it, don't you? Oh, see, okay, we're gonna get you.
That's why she wanted to bring it, cause she wants you to.
Okay, we'll get you tuned up. The one on your phone, guys, is easier to use than the handheld, I'll tell you that.
Really?
Yeah.
Yeah.
Oh.
And it's accurate. I worked with a bunch of guys at Pima County Road Department over in Arizona, and they turned me on to the phone one. Boy, we shot the hand one, and then we shot the phone one, and we came up with the same number the phone ones are. Is it on your phone?
Wow.
Is it clinometer on your phone?
No, I got the.
Show it Jeremiah, and come prepared.
Is it an app that you can download
Yeah.
or?
It's an app.
I downloaded it last night.
Oh, nice.
Okay, here's where you screw up. Not using the clinometer to verify road slope, drainage slope, and reverse grade on your rolling dip. Because I will guarantee you, especially when you get into marginal slopes, you're gonna screw it up. And I will guarantee you, if you don't build the rolling dip right and check it, you will screw it up. And the water will go over the top of the rolling dip. Right, Jeremiah?
That's right.
How many rolling dips did I screw up at Fort Union before Jeremiah said, what the hell are you doing?
I think some of those were knocked down by the drug grader as well.
Yeah, but you understand, yeah, but I started them, and they were 5 years old, but still. Jeremiah went up, we were doing some maintenance on the road at Fort Union that I did 5 years ago. And Jeremiah was right, I think we probably had it built a little better. But he went up and he shot all of them, the existing ones, and put some more in between because we hadn't put enough in. And he said, problem with this road is we got drains in it, but they're going over the top. So we effective, the drain's about half effective, so we collaborated and tightened up our deal. Okay, here's where you screw up. If you don't have a clinometer, you better get one. Okay. Not reading the landscape well and missing opportunities, we'll talk about this, opportunities to tie in landform, surface flow across the road, and especially missing small concentrated channel flows into the road, which include, you don't have this on your notes, roads coming into the road you're working on, cow trails coming in, and in this list of not paying attention, where you dump the water, you don't have a buffer zone. You're not getting it in a good grassy place, you stick it in some ditch, you stick it in some old road, that you just move the problem over. Okay, you wanna disperse buffer zone. Eric shaking his head, got it. Okay. Oh, let's see, not draining the road at the top of the hill and at a point in the road where the grade steepens. We'll just use this. Okay, lots of times here's the top of the hill, but this kind of grades out. It's still coming in, right? It's still sloping in, and it almost looks flat, but this is why you need a clinometer. You shoot back on that road and go, my God, I got 2% coming down this road. Well, guess where the water's gonna go? As soon as it breaks this hill, what happens to water when it increases slope? Speeds up. What happens to road surface material?
You can
It adios.
carry larger classes.
We forget to kick a green in right side. Guys that moved down here, you guys at Romeo Park, that's that's when they've missed. I drove around by Vermeer Park and too far down the hill. But I got it. I got it, huh?
You gotta get off the machine.
Well, that too, we'll cover that one too. That's one of the next ones. That's the next one. Reading ahead. Designing and locating drain sighting off the machine and not on foot. You cannot see proper grade and location from the machine, and you will screw it up, and I have, okay? Design on foot from the top of the hill down, because you can see slope and grade better. Okay, you start at the top of the hill and you walk down to do this work, you don't walk up. And you dump water off the road as you go down the hill. So you're dumping water off, dumping water off, dumping water off. And you kind of got an idea of, you know, okay, I've broken this up, I've broken this up, I've broken this up. Okay. Yeah, you can't see off the machine. The other thing is, even if what I call fast track construction and design, where I'm going down a road, I haven't staked it, I haven't marked anything. I'll go down, I'll start, maybe I'll take 15, 20 minutes I've always driven the road first and kind of get an idea. I've driven the Turner's main road out a couple times, I kind of know what needs to be done now, but we need to get on front and look at it. But I get off the machine, walk down the road, sight my stuff, figure out where maybe just put a rock in the road or something, I don't, maybe a little pin flag or something, and then go back to work. Okay. Not getting enough material out of the drain to correctly build a good rolling dip cross drain. Okay, you just don't pull up enough material. Kristen, is it better to have more material or less material to work with? Yeah. You learned that one, didn't you?
Oh, yeah.
Yeah. You get up there and you waller around and go, I can't. It's not like, you can't make a cake without all the mix. Being in a hurry, slow down, do it right the first time. That's nipped my butt more times than you can imagine. Okay. Some of the fine work you witnessed on the road coming in, I was in a hurry. I was gonna touch up things and I just.
Was that you? Hey, Steve,
I did fix the mud hole.
Was that you?
See, I don't mind just, you know, I've already had my ass chewing my neighbors, the Turner brothers, you guys can get on me, but you know, there's an example. You know, we had, Turner brothers and I had a 5 o'clock meeting. We dumped the dozer out there so I could mainly fill that big mud hole at the bottom of the hill. You know, so anyways. Not taking the time and having enough material to build the correct rolling dip drain that is not a hump and a bump because it's not long enough. Making sure you build your structure long enough to accommodate the vehicles that use it. Okay, so some roads you'll put in a certain kind of drain, and others you're going to put in another kind of drain. I mean, same drain, but it's going to be bigger. You know, places where, like the main road out here, we got to accommodate a potbelly semi. You can't do this and drag the bottom of the, you know, you can't go over it at 45 miles an hour that you can drive on this road. Okay. But on horse trailers and stuff, you gotta have a longer, nicer, you know, rollout, you know. Still, you gotta have it high enough that it kicks water off. So you gotta think about, if it's some old funky road going to the windmill while you're driving down, and mostly the pickup truck, you still want something that's comfortable to drive over. But it doesn't have to be 60 feet long like you do for a semi, you know. So, not checking to make sure you have a reverse grade on the rollout, so water will not overtop the rollout. We kind of talked about that, but you need a tool and an instrument to do that. Leaving and or not removing berms or or not installing brakes in the existing curb. Just leaving bumps and humps, we like to see stuff. Here's the reason, and we're demonstrating the field. You dig this drain out to get your material, well, it has vertical sides on it. We lay those vertical sides back, that's the last two passes we make, okay, and push that dirt out. You know why? What grows on a vertical surface?
Nada.
Nada. So you lay it back. What grows on a windrow of dirt,
Weeds.
if they're lucky? Windrows of dirt are high and dry. So we do nice clean work and knock all that stuff down and track roll it. You know, track rolling has, and there's been papers written on this, actually by the Forest Service, wrote one. What do you leave when you leave the grousers, that's your bar in the track, leaves those horizontal tracks in there. What do you think falls in there? Seeds. Water. You know, track rolling really helps revegetation. Okay, you can, and also if you want to seed, we've done this where we had lost some of our, in this particular, we lost our cool season grasses on this place. And so I said, look, you know, we're gonna put in 300 rhododendrons on this place, you know. I said, let's track roll it, put in our cool season black grasses. We came back with a chain harrow and ran over it. Everybody know where the chain harrow is? Nobody? Okay. Ran over it and caterpillar guy. Ran over it. We had 100% germination. I mean, you're kind of lucky, but we had 100% germination. So we made these little nurseries, basically. Those get seed and we'll start spreading out. Doing, you know, as long as they stayed with their proper management. So everything we do, not only harvest the water, all our dirt work has to be left in a restorative manner that we can, that will benefit revegetation. Okay. Otherwise, you're just out there screwing stuff up. If you screw this up, put too many drains in.
It's like being at the grocery store, the door opens for you. Morning, everyone.
Morning.
Are you Jake?
No, from state.
You are
I'm Louis.
That's a good one.
Louis.
Yeah.
What's your last name, Louis?
Romero.
Huh?
Romero.
Are you the local rep for out here?
You have two that are coming, and I think they left a little later.
So what do you do, Louis?
I'm the equipment trainer.
Oh, sure.
Oh, yay.
Nobody knows how to run this dozer out here.
Oh, what's wrong with you guys?
I don't know. A whole bunch of dumb
We're gonna have to do something about that.
Okay. Oh, I forgot that one of our sponsors is Wagner Equipment. They help with some of the expenses of getting the dozer out. I forgot that. I knew I'd forget. Okay. Not installing enough drains. We're moving two things. Dave, when we drain the road, what two elements are we working with? Yeah, water and dirt. I like that, dirt. It's also known as sediment. Yeah, you know, and I'm just, the terminology, if we're dealing with water, would be sediment, that's what we call it. So, you know, we're just learning new terms, aren't we? Okay, okay. So, a couple things can happen if you don't put enough drains in. The steeper the road, the more the drains. Why? Yeah, but what does steepness have to do with?
Makes the water run fast.
Yeah, but what does grade have to do with
Speed and
the
force.
speed of the water? okay?
In the amount of coverage.
It's on the next page, but here, let me just jump to that. It's on page 8 of your book. Flip your, Bill's, you guys both open to page 8. Now we're gonna study physics. And this is a physical law. Okay, this isn't my opinion, guys. All right, you're dealing with physics. Okay, this is a universal law. Okay, this is not something Steve and Bill invented. Okay, basically what that chart says, when you increase the slope, at some point you double the velocity. Velocity times 2 equals you move 4 times as much sediment, 8 times the particle size. So, if we're moving a rock at 2%, let's say we move a rock at 2% of this size, 2 or 3%, and we double that, then we're moving rocks like this, and we'll see this on the road. So, why do we increase the drains when we increase the slope?
Reduce speed and
Excuse
volume.
me?
Reduce speed and volume.
Exactly. Right. Because it's gonna increase, you can't control that. Okay, that water's gonna get to running fast, so you've gotta break it up more. If you're flatter, you're not running so fast, okay, and you have your drains further apart. Okay, so we're moving water, you put enough drains in, you only move a small amount of water in each drain, and a small amount of sediment. Yesterday, who was with us yesterday? We looked at some stuff yesterday, perfect example. Somebody had put a drain in at the bottom of about, a mile road. What happened to that drain? It filled up with sediment because they didn't disperse their sediment along with their water. Kristen, have you had that happen?
Oh, yeah.
Yeah. So what'd you do? You backed up the road the next time and put another drain in. Yeah. Have you had the other thing that you can happen? If you don't put enough drain, you start stuffing too much water in one drain and you cut a ditch out there. So it's all in the book right there. But that's a good study. So we don't put it in enough drain. Okay, we pretty much went over this next deal about roads and the consequences of sediment as it occurs. Unmanaged roads create heavy sediment loads, which create extended problems in river geomorphology function, impaired fishery habitat, plugged up irrigation systems, and water treatment system. Poorly managed road drainage can be easily corrected and has many benefits. Okay. Any questions so far?
I got one.
Yes, sir.
What is the primary issue, the roads that you guys are building, and how they're draining, I take it, and how the crown, shoulders, and all that?
Right. And the big problem here is we got water running down the road and just blowing the road out. So we put the idea is to put the rolling dips in, put a hump in the road, take it off. And we call that water harvesting. Multi-benefits for not only the road, but the rancher. Because once we kick that water off, Louis, it goes back on the landscape to grow grass rather than going down the road, down the gully, and gone. So we're trying to keep water on the land by draining the roads correctly. in
I
essence.
noticed you have rocks way out on the side, then you have vegetation, then the road's like a one-lane road.
Yeah.
So are you guys venturing out there to actually build up your road out there where you could have? a
Only if
ditch?
you have to,
Only if you have to.
Yeah.
Because you wanna keep that
yeah,
vegetation.
yeah. The other thing is, that's the other, here's a good point.
Them rocks go out there when there's snow.
The more vegetation you have up against your road, the more, that you got to feed a cow or wildlife. The other thing is, that vegetation holds stuff together. Unless you gotta reach way out there for some reason, don't be doing it. I mean, you see these guys cut the back slope and they, you know, the narrower the road, the less water we have to manage. If the road goes from 12%, from 12 feet to 10 feet, we've significantly reduced the amount of water that runs down the road. Let's talk about water running down the road. Let's go to that right now. Some of you know this equation. Who can regurgitate this equation for me?
1 inch of rainfall is equal to 0.6 inches of precipitation per square foot.
Per square foot. This is a square foot, it's fraction inches. Impermeable surface, 1 inch of rain hits that, it equals this much water. What's the square footage of your roof, Carl? Plus or minus?
30 by 40.
1,200 square feet. 12 times 0.6. 6 times 12, 500 gallons. Right? Wait, no, that's not right.
720.
720?
720. So, you just get, when you're trying, you just get 700 gallons off this roof. So think about your roofs at the ranch. Pass it around, I want everybody to take a look at this. Visualize a square foot. Now, how many square foot a mile road? 52,000 square feet. Plus or minus. Okay, let's look at some numbers. On your bottom of this page right here, it's all written out for you. But will make some sense. We'll take a break here soon. I got rid of that old cow for it. Oh, I need this. Okay, using the equation of 1 inch of rain on 1 square foot produces 0.6 gallons. Okay, we have a 12-foot wide road, 1 mile long, will collect 12 times 52, 63,000 square feet times 0.6. This is just hitting the road, guys. This is not what's coming off the slope.
Yeah.
38,000 gallons of water. Okay, I used this example the other day. Tandem axle water truck holds 5,000 gallons. Everybody's seen a tandem axle water truck, that's a 5,000 gallon truck. That's 8 loads in that truck. Eric, if you take you guys got a water truck? No, but if you took a water truck out here on a mile road and runs quickly up and down the road and dumped 8 loads on it, okay, they have water all over the place. Okay, so 38,000 gallons of water. We, actually that, a typo. We derate, not delate. Derate this amount by, it's always a nice place to catch your typos. Why does it always happen here? You know, by 25% for infiltration, evaporation, et cetera, based on soil type, everything else. Now we have 28,000 gallons of water running down 1 mile of road. Please note that that's just on the road, okay? If, for sake of argument, what we've done is we've used, let's just multiply that based on, you can calculate this based on what the watershed above your road looks like and the vegetation cover. For sake of explanation, let's take collateral flow and multiply that number by 5. Okay, now we have 142,000 gallons going down a mile of road. Okay? This equals 1.28 acre feet of water over 3 miles. How many gallons in a acre foot? 332, something, blah, blah, something like that, 320,000 gallons. Acre foot is an acre covered with 1 foot of water. What's that worth? Does anybody, do you know what acre foot costs you down at Laredo if you bought water? If you bought an acre foot?
A farmer can rent it for about $80 an acre foot out of the river that you guys send down to us.
But what if you? I ain't flushing my toilet.
That's right. That's our
No,
only
but if
water.
you went out and bought it, I know in the Pewaukee Valley, there's arguments of selling water or not selling water. They're getting $20 to $30,000 an acre foot.
Truly.
I sell it to oil company for about 50 cents a barrel. That's 42 gallons. So divided 325 by 42.
Yeah, this is, it's worth something. Okay, is it worth keeping on your ranch? Yeah. So how many acre feet do you have allocated to your ranch between wells and surface water? You don't know, but yeah, you understand what I'm talking about.
Yeah,
If you had to go buy more,
oh, yeah.
but if you manage the water better, you got more, okay? And so this all causes a problem, okay? The average ranch has, how many miles of road you got?
Over 100,
Yeah.
100 so.
See, Vermillion, what'd you say, 200? 250 miles?
200.
Vermillion Park, 1,000 miles?
Mm.
500,000 acres. Mike, do you know how many miles of road you got?
Ocean, probably 6 miles.
Yeah.
Something like that.
And what, 10, 12,000 acres? What do you got?
7,200.
7,200. Okay. So you can do a road density calculation on that. But, it starts adding up. I put in here, this sounds about right from my experience, the average ranch has 150 miles of road on it, equals 64 acre feet of water per inch of rain, or 21 million gallons per inch of rain. Now, you get 16 inches of rainfall, not all of that runs water. And let's just say half of it ran water. Now, how many millions of gallons do we have to manage? Okay, this is a lot of, when you start looking at these numbers, it's significant. I can't remember the report that I gave to the CS Ranch when we got done, but we ran this calculation on it, okay? After 3 years of doing all their ranch roads, okay, and it was a pile of acre feet. Okay.
So basically, if you consider your roads a tank,
Hmm?
and how to use the water out of that tank to redirect it.
Or a collection system, yeah.
Collection
Yeah,
system.
but tank is would store.
Okay, I used the wrong word, but
Yeah,
basically.
well, no, but I mean conceptual, it's semantics, but a tank gives us a picture of something, but yeah. But it's a collection area.
Right,
It's like your roof.
mhm,
We know water runs off the roof.
right.
And we know if we put a gutter up there, we can harvest a whole bunch of it, and run that in there, So, So basically, yeah, the next thing is, you know, got millions of gallons of water hitting your ranch, is it worth managing?
Yes.
Yes.
Okay. Let's take a 10-minute break.